Hello, everyone. Welcome to the introductory lecture of this course. This course is about learning machine learning through doing an impactful research project. If you are a student who is currently studying, or if you are an industry professional and you would like to know how to transition to machine learning in a meaningful way, and if you want to conduct research and produce something tangible, this course is for you. The goal here is that we want to teach you how to learn certain concepts within ML domain, how to identify relevant and meaningful problem statements within that, how to conduct research in that, and how to produce something tangible at the end of the day, like a research paper or a conference presentation, or even producing a really nice code base which you could publish on GitHub repository. And by doing this activity, you should be able to make your transition from what you are currently doing into ML happen, whether it is in industry positions or whether it's in a research position in a university, mainly for masters or PhD or postdoctorate. So when we were designing this course, we had several ideas in mind, but finally we decided to structure the course in such a way that it should properly address complete beginners. Complete beginners meaning I don't want to assume that you already know Python or machine learning or linear algebra or differential equations or you are good at mathematics. So I don't want to assume any of these things. So whether you are already coming from computer science background or you are from mechanical engineering or civil engineering, it does not matter what background you come from. um, in this course I will assume that you are almost starting as a complete beginner. That being said, will we be covering fundamental theoretical aspects of machine learning? Will we be covering basic linear algebra concepts that underlie ML? No, we will not be covering that in the course because that is not the end goal of the course. Often there is a lot of disconnect between the the kind of things you learn in courses and finally the way you apply that in an actual research project. What we want to really teach you in this course is certain concepts within ML which will make you confident enough to pick up a problem statement within that and work on it, produce an outcome, and solve a problem. This is our end goal. In this process, you will learn bunch of theory, you will learn bunch of mathematical frameworks, you will learn how to use libraries and code, and you will learn how to produce output and how to communicate it in the form of a paper. And at the end of all of this, you should be comfortable to claim yourself as someone who is really good at solving certain problems within the ML domain. If we can make that happen, then this course will be a very successful course. Myself, I am Dr. Sreedath Panat. I graduated from IIT Madras in 2017. So my major was in mechanical engineering. So I come from non-ML, non-CS background. Then in 2017, I went to MIT for my PhD. I graduated as the topper of my dual degree department from IIT Madras. And even during my PhD, the department was mechanical engineering, but kind of work that I was doing was highly interdisciplinary. So it was an experimental lab. So I was building physical setups for solving certain problems. And one of the problems that I was exploring was how to remove dust from solar panels without using water. In this project, we developed an electrostatic technology for charging and repelling these dust particles. But there was a small problem here. The problem was, to charge the dust particles, we have to apply a certain voltage. And the threshold voltage that we have to apply heavily depends on the dust particle size distribution. And the problem was that it's very, very difficult to identify the dust particle distribution really quickly from an actual solar panel, because the particles will be belonging to different size buckets and there will be a distribution, and they are very small. They are tens of microns in size. So it's extremely difficult to identify the particle sizes. So this to solve this challenge is where I applied my machine learning expertise, which I learned through several projects and advanced graduate level machine learning courses I took at MIT. So we were able to develop a system where the ML model could bucket dust particle size into various distributions using a high magnification camera images that are captured. And using this, we could apply appropriate voltage and remove dust without consuming a single drop of water, and recover up to 95% of the lost power output due to the dust accumulation. This was a very satisfying journey where I could apply my knowledge in ML, not just in a theoretical framework, but to a problem of practical relevance. And after the paper associated with this work was published, we even had collaborations with NASA, where they are now currently trying to solve a problem where the rovers that are sent to Moon and Mars, when these rovers land, the Martian or lunar dust accumulates on those panels, and uh, it can essentially kill $1 billion mission, or even significantly reduce the life duration of this mission. So they are trying to solve this problem, and they are trying to see how they can incorporate similar waterless electrostatic dust removal technology, which is a robotics plus ML based system, to get to work on Martian and lunar rovers. So the impact of knowing how to apply ML techniques into real world research level problems is very huge. And I was also a complete beginner 5 years before, and I could make the transition happen by working on problem statements that are more relevant for industry and more meaningful for research settings. So this is exactly what I want to teach you through this course, where how do you, as a complete beginner, start learning some concepts around ML, then apply them by identifying good problem statements, and then at the end of it produce something tangible. This is the goal from this entire course. So you can follow me as I walk you through the course. So the way I am planning to structure the course is such that I will also assume that I'm a complete beginner, and I will walk you through without assuming that you know anything, right? So that way I can ensure that most of you who are uh, part of with me in this course are able to follow through the course, and you are not dropping midway, and at the end of the day you're able to produce something. And initially we were thinking, while designing the course curriculum, we were thinking we could produce something like a generic course material which will teach you how to tackle problem statements within ML. But then we thought it will be too broad, and it may not necessarily teach someone how to actually do work on projects within ML. So then what I decided was, I will pick a specific area within machine learning called explainable AI. So explainable AI is a topic that has gained tremendous attention in the recent years, mainly because, as all of you might have heard of, machine learning models like neural networks, they are black box models. So black box meaning there are set of inputs, it goes into the model, and it produces an output. What happens inside this model is not very easy to interpret. So let's say uh, you are a human and you are in a self-driving car. Would you trust being in a self-driving car if you are in a highway in, let's say, India? Would you trust the decision of a machine learning model even if you know that the accuracy of this model is 99.999? That's a question. Are you sure that the ML model is seeing the road and everything as how you see? How are you convinced about this? How are you not sure that the result, the percentage accuracy produced by this model is due to some bias in the data? How do you know this, right? So it is extremely important to have interpretability for these machine learning models, even if they have very high accuracy. Only then a human can trust the model to actually deploy it in large scale. So now what is happening is companies and government organizations, especially since now generative AI is coming up and AI is actually becoming large scale, everyone is trying to see how to make models not just accurate, but also interpretable and trustable. And this has widespread applications in medical field, finance, in automotive industry, and several other industries. So explainable AI is the subdomain within machine learning where the goal is to um, introduce interpretability into these black box models in a broad sense. So in this course, I will be teaching you the concepts, underlying concepts behind explainable AI. I will, of course, also teach you several basic machine learning concepts. So you don't have to worry if you don't even know ML in the first place. So you might be wondering, you don't know Python, you don't know ML. So how can you comprehend explainable AI? Is it possible to even start your journey there? So don't worry if this thought is occurring in your head. The course will be uh, rightly paced for your convenience. And I want to make sure and I want to take the best possible efforts to ensure that you are following through the course content. So I'll be teaching you the concepts within ML and within explainable AI, the theoretical and mathematical framework in a slow and uh, reasonably easy to understand way. And I will also teach you how to apply these techniques into small problem statements first. So I will code with you. I will sit down and take notes with you. I will create PowerPoint presentations for teaching you certain concepts. And each lecture will be structured such that it covers one major concept. And after learning how to apply explainable AI techniques to small problem statements, I will show you how to pick a research problem statement within explainable AI and conduct a research on it. So here I will not be picking a very difficult problem statement deliberately. I will try to identify problem statements that are kind of low hanging fruits. So by low hanging fruits, what I mean is problem statements where there is a data set availability, there is some well defined boundary where you can pick the problem statement and start working on it. Make, let's say, if you're building a model, make the model a little bit better and produce slightly better results, and then interpret your results and derive conclusions and write it in the form of a paper. So I will work on a paper myself and I will walk you through the journey of this, starting from identifying the topic, identifying the data set, how to write the first piece of code for this paper, how to modify it, how to get good results. And once we have the results, how to create figures for the paper, how to write the bullet pointed outline of the paper, and how to write the full paper, and finally identify journals or conferences to which this paper can be submitted, then submit the paper, along with cover letter to the editor and try to get it published. So I will walk you through every single step in this process, and I will also help you identify similar problem statements that are low hanging fruits, so that you can pick one of them, or you can pick even slightly different problem statement yourself and start working on your own research parallelly. So that's my goal. So get ready with your note taking. uh, Keep your coding environment ready. I'll let you know what to pick, so don't worry about it right now, but I'm saying for this lecture and future lectures, keep your everything ready and follow with me through the course. So if there are coding assignments, do these assignments uh, as part of every lecture that I'll be putting here. And when we are writing paper, you can also pick your problem statement and write along with me, and let's see where it takes us, right? So this is how we are structuring the course. If you have doubts, or if you get stuck somewhere in the course, of course you can feel free to ask questions. I would love to help you uh, clarify your questions, or I would love to help you get unstuck in the best way possible. So now I will uh, show you what is the detailed course structure, um, which I have prepared, but I don't want to spend too much time on that because you will see it as we progress through the lectures. So let me get into that. So this is a document which I created in a website called Notion. So notion.so, Notion. So I created this. So all the material which are part of this course I'll be collecting here. The course module structure, the papers that I am referring to for as part of this course, if there are any useful Kaggle notebooks, those things, any other YouTube course videos or any other videos which may help, useful GitHub repositories, any other code or other useful links, everything I'll be collecting here. So, and I'll be sharing all of these with you as part of the course. Now let's look at the structure of the course. So I have divided the course into several different modules, and each module will have more than one lessons. So introduction module is the current one, which will cover the course structure mostly. And then from module 1 onwards, we will go through the concepts behind explainable AI. So here we'll be going into the details about what is explainable AI, what is the history of it, in what fields are it becoming relevant. And then from module 2, 3, 4, and 5, we will learn actually implementing certain popular explainable AI techniques like LIME, SHAP, etc. So in module 2, 3, 4, 5, you will be actually running code, and you'll be applying these techniques to certain problem statements, big or small. And then we will look in module 6 to 10, we will look at implementing explainable AI for different types of data sets like image, tabular data, text-based data, or graph neural networks or large language models. So we'll be looking that through module 6 to 10. And from module 11 till module 17, it's all about working on a research problem statement. So here my goal is I will identify certain relevant problem statements within the confines of explainable AI, and I will pick one for myself and I'll work on that. So as I shortlist the research problem statement, as I conduct literature review, as I write my own code for generating results, and as I make the figures for the paper and crafting the outline of the paper and finalizing the paper, as I do all of this, I will share the learnings and steps that I take with you. So as you go through these modules one by one, you will also learn how to do this yourself. So I highly recommend you to, as the modules are progressing, you can also follow the same step. So if I'm identifying relevant problem statements and if I'm shortlisting a certain problem statement, you can also do the same. You could shortlist a different problem statement, which I might have already mentioned in the module 11. And then once the paper is finalized, we'll also talk about other interesting research problem statements, which you can potentially explore for the future. And finally, the end goal of this course, as I mentioned, it is to make you job ready and to make you research ready to work in this particular domain. So we'll be covering that in module 19 and 20, how to really prepare to be part of research groups working on problem statements in XAI, and also how to apply for jobs as an AI expert within Explainable AI. What all kinds of companies are looking out for people like you, and how to apply for those jobs and get them, right? Here I'm showing how each module gets divided into different lessons, and within each lesson, what all subtopics will be covered. I don't want to go into complete details of this, mainly for two reasons. One is we will anyway be covering this in so much detail. But one small caveat, one small thing I want you to notice is that the exact modules, exact lessons, and exact topics, they are a little bit tentative. Tentative meaning, for example, let's say Explainable AI in graph neural networks and LLM. These module 9 and 10, in my mind, currently, it's a bit tentative. Like I may or may not cover it fully in full detail. Similarly, the let's say layer-wise relevant propagation or counterfactuals or adversarial examples, these modules, it may not be 75 minutes in total duration. I may cut it down or I may increase it in size based on how the rest of the course is progressing. So, but that being said, the structure for the most part, what is shown here will remain, and you can have a look at it briefly. Don't worry about the structure if it looks too intimidating or too much for you. I guarantee you it's not going to be very difficult. As long as you follow lecture by lecture, module by module, everything is going to be very smooth, and you will have a very, very good time learning this, applying this, and creating something tangible at the end of it. So if I make changes to the module structure, I will let you know through the course itself. And you can expect certain changes. This is only a tentative course structure. If I find a better way to put some of the concepts together, I will of course be implementing that. So just wanted to share the course structure with you to keep the expectations right. Now here, I am pretty sure that when you see these things, when you see local interpretable, model agnostic explanations, all of these things, you may be wondering, oh, this is not meant for beginners. I don't even know what is AI, and then how can I learn Explainable AI in module 1 itself? I don't know too good how to code using Python. I don't even know linear algebra. Are all these things meant for me? If you have questions like that, don't worry, because it's okay even if you are a complete beginner without too much grasp on any basic concepts within ML, because ultimately for applying these Explainable AI techniques for different data set and making interpretations, knowing the mathematical frameworks or mathematical concepts behind machine learning is not mandatory, although knowing that will be really good and helpful for you to build an intuition. So you can slowly learn all of that, but please don't be worried if you don't know if you don't know those concepts yet. Just with conviction and faith, you can start working on this, and slowly we'll advance together. And as you learn, I also wish to learn, and if you learn something new, feel free to share those things, and we can take this journey together, and let's produce something at the end of it. So this is a course where you actually do things, not just watch lectures and go back and come back again without doing anything in between. So this journey is, I am as excited as you are, and I look forward to seeing you in the rest of the lectures in this course.